what if we wanted to make this just a little bit more interesting and complex? So what I mean by that is, let's say we've got our cylinder here, and we have this back and forth motion, but we don't want to animate the spin. We want that spin to be automatic. This is something that a lot of people ask for in class 1 regarding the bouncing ball and how do you get a perfect roll and how do you get the math in there. Honestly, for most animations, just animate manually. That's the best way to do it. I say this with full sincerity. Trying to find the mathematical rotation is more work than it's worth, and most of the time it's not going to actually look that much better. Or if, in many ways, the mathematical equation is going to make it look worse. So we don't want to do that. But what if we do want to set this up? Maybe for like a car rig where we want to just drag the car forward and the tires spin just for us. We don't have to do extra work. What if we want something like that? Have this automatic rolling motion. How can we do that? Well, this is where we start to get into a little bit of that rigging elements here. So if people are interested, we can go. I should actually ask, would people be interested in learning how to do that? Or would you rather go straight into feedback here? Because this is like, it's not really animation related, it's more rigging related. But I don't know. Is that something people would be interested in? Let me delete these, simplify theme. Yes, rig? Okay, cool. Okay, yeah, we can do it then. Let me take a sip of water here. Okay. So, this is going to be the basics of setting up a adjustable and animatable self-rolling object. So let's take our cylinder, and I'm going to create a new one here, just so we have everything fresh. So we're going to take our cylinder here. I'm going to rotate it 90 degrees to the side, and then let's leave it at its default scale for now. Now, once I rotate it, I want to roll it on its side, so it's kind of like a tire. So I'm going to take this and I'm going to go to Modify, Freeze Transformations. This makes sure that all my translations and scales are set to 0. This is always good when you're about to do some sort of rigging thing. Now, the concept here is that we need to know a little bit of math and think through how we're going to do this. So the key to getting a roll to happen properly is that we've got our spherical object, circle-ish. We need to know how much to rotate it versus a full rotation. So a full rotation is 360 degrees. So from this point, rolling all the way around, back to that point, that's a 360 degree spin. That's great. That's easy. But how much is that value actually going to be compared to the translation? That's the key. It's easy to spin an object. Yeah, 360 degrees, no problem. Full spin. But if the object is smaller and it travels a certain distance, it's going to need to spin a different amount than a huge object rolling that same distance. So we're dealing with not just rotation here, but translation. This is where it gets trickier. We need to have a relationship between these two for this object. Now, the way we figure this out is we need to know the circumference of our circle. What is the actual size of this circle? How much space is this, the length of it? Now, for anyone who remembers math class, the calculation for circumference is circumference equals 2 pi r. So 2 times pi times r, which is the radius. The radius is half of the diameter, the width of the circle right here. So if we have this, we will know the value, how big the circle is, and then we can use that and essentially divide that number by 360, and that will give us the amount to rotate the object. So we've got to do a little bit of math here. Right there. So let me go through here. So the way we do this is, let's go back to Maya. We already know some of these values. So we've got 360, great. We know 2, well, that's easy enough. Pi is 3.14. So we can already simplify this to C equals, if this is 3.14, is going to be 6.28 times R divided by 360. So, with all of that, all we need to do is find out R. That's the big thing we need to find out, the radius. Now, in Maya, when you first create a cylinder or any round object like this, if you actually go into the inputs, there's our radius right here. The radius is set to 1 right now. If I was to take this and scale this up, maybe make this bigger, now it's got a radius of 10. There we go. So that's our value. Once I set this, I can just set this to whatever size I want. I can use this as my measurement tool. But what if we don't have that? What if I just had this cylinder and I scaled it up and I was modeling and doopy-doopy-doo, I make a nice tire, da-da, ba-da, and then modify, freeze transformations because I wasn't thinking about it. What's the radius? Who knows? What we need to do is we need to measure that. So I'm going to go to Create, Measure Tools, Distance Tool right here. And then I'm just going to hold down V to activate snapping, and I'm going to snap a measurement from the center right here to the top edge right there. There's our measurement. That's our radius right there, 7.88. So, boop, there's our radius. So this is the number that we're going to have to use. So let's make this a little simpler for ourselves. What did I hold down to snap? I held down V. V as in Victor, or vertex. It allows you to snap to vertices in your scene or points in your scene. You can also use this button right here. It's the same thing. So if you hold down V, you'll see that it activates that up there. C is curve snapping. C as in Cameron. X is grid snapping because X looks like a grid. And then, yeah, V is vertex or point snapping. So let's simplify this. I'm going to go back to this here and we're just going to set our radius. Let's go 12 just to have a kind of random number here. Okay. So our radius is 12. I'm going to modify freeze transformations here again. And ideally I would delete history, but we're going to keep this around just for now, just so we can see it. Okay. So we know that our equation here is the circumference equals 6.28 times 12 in our case right here, divided by 360. So I should put it like this: circumference divided by 360. This would be the mathematical way of writing it properly. So like that. So with that, we just have to multiply this. And this is where our calculator in the computer is very handy. I can just take this 6.28 times 12. There's our circumference, 75.36. There we go. And actually, wait, I'm trying to think here. I think I might have gotten it backwards. It might be 360. Yeah, it's backwards here. It's 360 divided by Tired brain. We go the other way. Honestly, both ways would work. It's just, it makes it a little easier if we go this way. So we want to take 360 degrees and we divide it by the length of the object, the circumference. A lot of math, a lot of like going through this. But honestly, once we have this, it's not too tricky. So we have this value. Now we could calculate that if we wanted to. So once again, let's find our calculator right here. So let's clear that out. 360 divided by 75.36, 4.78. There we go. This is the value we need to use, 4.78. For this specific sphere, that's going to allow us to rotate this perfectly. How do we do that? Essentially, we need to take our translation times 4.78 equals our rotation. That's what we need. How do we do that in Maya? We've got our translation. So let's say this is going to be our translate x here. We take this value and we have to multiply it by 4.78 and then input that result into our rotate z here. Okay, how do we do that? The way we do this is with the node network. So if you go to Windows Node Editor, nodes in Maya are all the connections in Maya and how things work together. So I'm going to take this cylinder and I'm going to graph it out by hitting this button right here. It's the two arrows in a box. This graphs out all the connections that go into this cylinder. And these are all the different pieces that we're going to be using here. Now, the main thing that we want is to select the P cylinder 1 node right here. That's the one we see right here. Just look at that name. And if we open this up by clicking on this hamburger menu right there, there's our rotate, scale, and translates right there. Or let's open it up so it's the full thing. There we go. And a lot of other attributes, which we won't need. Actually, let's just simplify that. There we go. So we've got our translates and rotates right here. So I can take my translate x and pump that into. So translate x, I can just drag this back into my rotate z right here. And you'll notice that it kind of creates this little loop. I've connected those together. So now if I move my translate x right here, the object rolls. Both values equal the same thing. Now, that's a good question. Can you use the node editor for constraints? You can. It's mostly used for connections. So it's like an advanced connection editor. But you can set up your constraints this way as well if you wanted to. So here I just did a straight connection. That's not what we want. We need a multiplication in there. So to add new nodes in here, just hit the tab key and this will activate your search box. And I'm just going to type in multiply, if I can spell. Multiply. And I want a multiply divide node right here. This will allow me to take an input. So input 1, put that in there, and it's going to multiply or divide it by input 2 right here. So to set this up, I'm going to take my translate x, that's the forward motion. Let's put that into input 1x right there. And then we're going to multiply it by input 2x. The x is multiply, the y is multiply. Since we're only using one value, we don't need to do the whole x, y, z. So input 2x, this is where we put in 4.78. Right there, that value that we found. There we go. So input 1x is now going to be multiplied by input 2x. Then we take the output, so the output x, the output of those two, and we're going to pump that into our rotate z. So we're doing this loop here. Let's see if I can lay it out in a way that kind of makes sense. Yeah, it crosses there. So it's going in. That unit conversion is just converting a translation value into a rotation value. So that's why it's got that extra node there. So with this, let's look at what we're getting now. Hey, that's better. You can definitely see that it's rotating much faster, but it's going backwards. Dang it, what went wrong? We need to inverse that number. When we multiply it, we don't multiply it by a positive value, we multiply it by a negative value because it has to spin the other way. So negative 4.78. Now, perfect rotation. Done. There we go. We've got a wheel that spins. So a lot of that to say that all you really need to do is you need to find the circumference of your object, take 360, divide it by your circumference, and then take that value and connect it with a multiply divide node. That's it. Simple apply. Now, there's a problem with this, which is what happens if we start scaling the wheel? If I make this wheel smaller, put it on the ground, it's not going to roll anymore. You can see that it's slipping. If we make this even smaller here, you can really see that it's slipping on the ground. It's not rotating anymore. This means I'm going to have to do all the math again to find this dimension here. That's kind of a pain. There's a few different things we can do with this. One is we could keep track of what the size of the wheel is. That's possible. We could make like a wheel scale attribute here that we could use to scale up the size of the wheel. That would work. We can also use the distance tool. So if I create the distance tool, let's see if this will actually work here. I could snap these values, doop, right in there. Make sure, okay, good. If I do this, I believe, if I remember correctly, as I scale this, no, it's not going to work. I would need to take these locators and I would need to constrain them to the vertices. So if I take the vertex, then the locator, go to constrain, I can do a point on poly. Same thing here, vertex, then the locator, point on poly. Now if I scale this, ideally, there you go. We now have a value that is constantly matching the size of our wheel here. There we go. So with this, we have this value here. At this point, and this you can do this in all ways. You can do this with a displace or a distance marker. You could do it with a scale attribute if you want to create a whole bunch of attributes. Whatever you do, essentially we now have a value that we can use. All we need to do is make a network that calculates this for us. Instead of us having to do all the math ourselves, which is like all the math here, taking 6.28 times the radius and then 360 divided by that, we just need to do a network that will do it for us. So I can take my network here and let's simplify it. Or not simplify it, make it more complex. The opposite of simplifying. That's the word I'm looking for. 3 hours of sleep is not enough. Get more. So we're going to have a few multiply divide nodes. I think 2 is all we'll need, but I'll make another one just in case. So we've got all of these in here. We also need, along with all of these, to have our distance in there. So if that's an attribute you add in here, great. If it's your distance right here, you could bring that in. And we need the distance right there, this value here. Now let's actually make this so it's a little bit easier to see that distance. Just for simplicity, say this is going to be an extra little thing. Maybe I want to be able to see, to select my object here. I just want that distance listed right here in the channel box for some reason. just to see what size this wheel is. If I want to do that, I can select my P cylinder. I'm going to go to modify, and I'm going to add an attribute. It's going to be a float, which is just a decimal value, and I'm going to call this the radius right here, like so. Done. Here's our radius. Now I want this radius value to equal the distance. So the distance is going to pump into radius here. And hey, take care, Lucas. Have a great day. It was nice to see you again. And also, again, congrats on the job. That's awesome. So to connect these, I'm going to take my distance, open up my Windows General Editors connection editor. I could do it in the node editor, but in this case, I feel like this is just easier for me. And I'm going to find my distance. So right here, the distance value. Right there. And let's actually, just gonna double check something here. Distance. Trying to find where the actual value is stored here. Oh yeah. Right there, distance. So that's the value right here. So if I look through here, it should be in here. That's why. So you'll notice I can't find it here. Why? This is because I'm not looking at the right node. I'm looking at the distance dimension here. But if we actually look at our attribute editor, the distance here is in the shape node. This is always an interesting thing to watch out for. The shape node is another node attached to the main selection node. So what we need to do is make sure we have our shape node here selected. So to do this, I can select the shape node here and hit focus, and that selects the shape, and then reload there. Or if you want to just do it visually, go to display, show shapes, and I can select the shape node here. There you go. There's our distance. So you just have to know which node it is. And again, nodes are just all of these different little bits of math that go in together to make things happen. So distance is going to connect right into our radius value here. Radius. There we go. Now, when I scale this up, you'll see that radius updates automatically for me. It's telling me how wide this circle is. There we go. Now, let's graph out our cylinder again. So we've got our distance right here. Our radius. So I don't really need this right here. You can just move that out of the way. And let's just simplify this. There we go. So we've got our cylinder right here. Let's make our multiply divide nodes. So hit tab. That's not tab. This is tab. Multiply divide. Okay. So if you remember what we need to do, we need to take our radius there, multiply it by 6.28. So let's take our radius. We'll put that into input 1x. Input 2x, we're going to put in a manual number of 6.28. Okay, there we go. So that gives us an output x of our circumference right there. And this is where it's good to name things. I would start naming this and call this multiply, just so I know it's a multiply node. Multiply. And then this is circumference. Or you could just put it C or something like that. There we go. Okay. Let's add another multiply. multiply, divide, and that's the wrong one. My eyes are crooked today. Okay, multiply, divide, there we go. So, what's the next thing we need to do? So we take this value here, and we divide that from 360. So 360 divided by that radius, or sorry, circumference value. So we're going to take 360. So this multiply, divide, 360. We're going to make sure it's set to divide right here. Very important. And then we're going to take the output of our multiply circumference and bring it into input 2 here. So we divide by that value. So 360 divided by that. And this is going to give us our, let's see, multiply. And this is going to be our 360 degree. There we go. Or I should put divide, but it's a multiply divide node. Okay, from there, we now have this value of, well, we used to have 4.78. This is the amount that we need to adjust into the translation right there. So now we have to take our translation times this number and put that into our rotation. So we need one more multiply divide. There we go. And we're going to take this, take our translate x, in our case, put that into input 1x, take our output from our multiply 360, take our output x, put that into input 1x, is going to multiply right there. And from here, we now take this and pump that into our rotation. So we're doing exactly what we did before, but we're doing everything through calculations now. So with this, I think I put it into the wrong input. And for some reason, it's all zoomed out. So let me bring that closer in again. So where's our multiply divide? Right there. Output 1x into rotate x. There we go. Oh, sorry, rotate Z. That's why it's not working. Get your sleep. It's better. Your brain works better. Okay. So we've got that in there. I think that should be set up. Now, as I translate that, it's rotating, but it's going backwards. Once again, we need to make sure that we're multiplying by a negative value. So I'm going to take 360 here and go negative 360. Now, it's rotating the right way. And with this, because we did all of the math within Maya, if we now change this and shrink it down, it will rotate perfectly regardless of the size that we have this at. So I can just roll it around. There we go. And even if I take this, because I'm not calculating a value on this object, because I'm using a distance tool, I can now group my cylinder here, put this on the ground, and I can now scale the group here and keep that tire on the ground, and then I can just and it rolls. There we go. So we get that perfect roll all the time. There we go. So yeah, that's how you do it. I hope that made sense. I know it was kind of a lot of back and forth and not the most like succinctly explained. I wasn't actually expecting to go into all of this. It was going to be simple, and then it got distracted. But yeah, that's pretty much it. We're just doing a little bit of simple math. And with this, we now have capability of making something really interesting. So if you have a character riding a bicycle, you can have this go through and done. Now, On top of this, there is one thing that I would want to do with this. Let's say this is a car tire, a bicycle tire, and you're sitting on the bike and then you like just spin the tires and you're on looster and the tire just goes shh, and then the bike goes off. Or if you're in a car, you hit the gas, the tires are squealing on the pavement, they're turning, you're burning rubber, and then the car takes off. How do you do that? I can't rotate this now. It's locked. I cannot change that. How do I now adjust that value so that I can animate the tire spinning while also having it move along here? I need another multiplication or an addition, essentially. So we squeeze the floor. So what I'm going to do here is I'm going to add one more value here. So I'm going to add another attribute. And let's call this tire spin. Right here. This is going to be an attribute that just allows us to add extra roll in here. And what I'm going to do is I need to take this value. It's just going to be like a regular, think of it like a regular rotation value. I want to be able to take that and add it on top of this value. So the rotation value here that's coming from our multiply divide and pumping into the rotate Z, I need to, let's see, where is it? Multiply divide. It's in here. Okay, yeah. Unit conversion into there. So I need to take this value here and add on top of it. So to do this, I'm just going to create an, it's called a, is it addition? No. What's the name of it? So this is actually a good point. If you aren't sure what nodes you have available in Maya, how do you know what nodes to create? How do you know what to type? So to see the nodes, go to the reference, or sorry, the, why can't I think of the name? Hypershade, that's it. So we're Windows Rendering Editors Hypershade. This is a rendering menu, but it also has its own node editor right here. And it also has a list of all your nodes right there. If you go to your utility nodes, this is where you're going to find a lot of the multiply divide stuff. So what I want to do is add a addition one, and I'm just blanking on the name because my brain is, plus minus average. Yeah, plus minus average should be the one I'm looking for. Just double checking, see if there's anything better. No, this should be good. So plus minus average. I'm just double checking. Distance. Float. Split divide. Yeah, that should do it. So we're going to take a plus minus average node. And we're going to take our output here from our conversion node here. Let's put that into the input 1D right there. So multiplied is or plus is a little different, but it's acts pretty much the same. Then input 2, we want to add the tire spin value in here. So let's put it into input 1D1, I think. I don't use these that often. So we're going into there. So for item 1D, we've got these two values, and it should sum them together. Let's see if that works. So we're going to take output 1D, and now take that and put it into our rotate Z. So let's see if this worked. Nope, I broke something. Let's see. I feel like I'm overcomplicating it. There should be another node that's a little easier, but I can't think of the name of it. 2D. Play. I can use the plus minus. It's just, It's a more complicated node than we really need here, but we're just going to do it anyway. So plus minus average, let's see. So it's going to sum 1D. It should be plus input 2D. I think. Let's see. Play around with this. So where's our node? So unit conversion. Let's actually, I'm just out of curiosity, I'm going to just take our raw value here, put that in, and see if that was the issue. So input 1 there, tire spin, comes in there, output into rotate Z there. Yeah, I think that should do it. Yeah, so that was the problem. I was using the unit conversion when I wasn't supposed to. I wanted to use the raw data. Okay, so with this, we now have the spin working right here. It spins around. But if I need to have it like just go crazy, I can spin it right here. Now you'll notice, dang it, it's going backwards again. Honestly, it really just depends. I would want, like, if this is the forward direction here, I would want this value to spin the other way. That's just like a user issue. It doesn't really matter because I could just go into the negatives. But if I want to make it a little bit more intuitive for myself, I need to multiply that value by -1. So this is where it gets, let's just, for the sake of it, since we're going super complex here, I'm just going to add another multiply. Okay. And I'm going to take that tire spin value right here. It's going to come out, go into input 1x. Then I'm going to multiply it by -1. And then take that value and pump it into input 1D here. So now, as I spin it, yeah, that works the way I would want to. And yes, you can rename the nodes. So in here, like I stopped doing it just because of time, but we've got our multiply circumference, multiply 360. This would be our, let's see, let's just call it mult. And this would be our, let's see, times translation right there. So it's multiplying the translation. This plus minus average is add tire spin. So you can name these whatever you want. Add tire spin to rotation. This is reverse tire spin, which also reminds me, like I use a multiply divide node. That's what I like to use. You can also use a reverse node. A reverse node takes a number and then just flips it backwards. So a positive becomes a negative. So you could just do that instead of a multiply. So there we go. So now we can name everything. Let's graph this out so it's a little bit clearer. There we go. It's still a mess, but we have this now. We can roll this, and if we need to have that tire actually burn rubber, right there, we have full control. There we go. So we can still animate on top of everything else. There you go. So hopefully that makes sense. I know, again, it was very rough and like just throwing things together, but this is the fun part of, like, at least for me, knowing a little bit of rigging and like the node editor and all these connection editors and stuff. And like we were showing before with the board on top of the cylinder, if you know these kind of tricks in Maya, you can make something that makes animation a lot easier in certain cases. So I could have this set up here, and I can just attach it to a car, and as the car moves forward, the tire just spins for me. I don't have to try and animate the tire. And if I do want the tire to have a nice extra little bit, I still have that control to add that in. Now, with all of that said, how often would you use this in animation? Unless you're dealing with like a car rig or like a bicycle rig or something like that, if it's just a rolling sphere, I would never use this because it's just more work than it's worth in most cases, especially for a short scene. It's much easier to just have the ball roll in place and then you just make the rotations work. This is just extra. You don't need to do this. And in many cases, it might not be really nice because then you have to like, okay, tire spin here and then counter rotate something else if I want the ball to spin a specific way. It's more trouble than it's worth. But for a car rig or something that is going to be rolling for a long time, or if it's going to be rolling in a very specific way, this can work really, really nicely. So yeah, hopefully that was interesting. Hopefully it was, it made sense.